Welcome to Solar School. I am excited to present the work we have carried out in civil engineering at Cox Energy. We begin by locating the project plot and the perimeter wall that bounds it to the south. To the east, you will find the entrance and the existing plant in Evora. The zero level of the plant is also established, beneath which lies the drainage network, designed with the same criteria as the existing system in Evora. For rainfall data in Evora, we utilized information provided by the Evora Meteorological Station for the period from 2013 to 2024. The design includes ducts and prefabricated concrete manholes. The water area has basements for the water systems, tanks, pumps, and coolers. There are two slabs. The water pump and the tank are in a different foundation from the cooler's basement, which is a flat area with an anti-vibration blanket, which sits on a thick slab. The next auxiliary is the air compresses tank. A thick slab includes the air compress tank for instrumentation. In the northwest, we have equipment containing molten salt and the electric heater from SECO. From the initial slab estimation as a complete cube, we designed a concrete footing braced by a tie beam under the zero level, with all supports reinforced with steel. The electric area is located in the southwest, where the transformer and electric building are situated. The slabs are simple, flat, reinforced concrete, with only a 10 centimeters thickness required for the electric building. The CO2 system includes the heater and recuperator from Lointec, a CO2 repository, external supplier Nippon Gases, Baker Hughes compressor, and Franco Tassi Mechanica turbine. The recuperator is a heat exchanger nearly 6 meters long, supported by one fixed support and 3 sliding supports. The heat exchanger H1002 has 10 meters in length, 3 sliding supports, and 1 fixed support. The foundations for this equipment consisting of 2 concrete footings and a tie beam, equal to the heater H1003. The CO2 supply is on a flat slab measuring 7.5 meters long and 3 meters wide. The compressor area includes a reinforced slab with 1,180 kilograms of steel for the compressor skid and a small foundation for the oil mist and its cooler. The turbine basement has 3 areas: the lower support for the DSG console and lube and control unit, and the upper support for the generator and turbine set, with a height of 1.5 meters versus 0.35 meters. After we have described the civil works and taking advantage of the 3D model, we will look at the piping and supports in the sales area, the inlet and outlet connection pipes of the existing tanks, and the drainage collection. We can see the piping for molten salts and their supports, which have been simplified to reduce the number of typical foundations. The sliding points are mandatory for these types of supports. The water piping is designed in polypropylene and connects the water tank with the coolers. CO2 piping required extensive design hours due to limited space and the need for loops to minimize stress. All lines connected to mechanical equipment or with temperature must be STIRS calculated. The instrument's pipe tapping is included, and there are only a few lines that are not definitive. The CO2 collectors that carry the gas to be cooled before re-entering the cycle are designed and calculated. The piping supports are designed after the lines fulfill all the requirements, including the stress calculation. The silencers need more strong support, and all the lines connected to them have to be calculated too. Details of the supports are crucial, as sometimes only a small part of the foundation is visible, but there is a buried foundation. Most of them are simple, only one support or double two supports in the same foundation. The 3D design includes all the information for each pipe and element, including electrical heating, insulation, pressure, and temperature, as well as safety pathways and spaces for operation and maintenance. All the plant area has safety ways. We can see their volume in green. There is near the equipment enough space to work. We can see near the turbine spaces for work and maintenance, or the spaces for heaters. From our part, that's all. Thank you very much, and we hope you enjoyed this virtual tour of Solar School. The next step is to build it. Let's go for it.